the first problem we're going to work is involving different problems that have nomenclature and compounds associated with them. This is the first question problem set, and we're going to look at it with respect to naming primarily. First thing is this compound here. This is lithium borate. Borate is one of the polyatomic ions that we were memorizing so that we could use them. This is an ionic compound. 3 is a molecular compound, involves only nonmetals. So with it we are going to use prefixes. So it's diphosphorus, penta, sulfide. The sulfide being an individual element. For B, we're going to use the chemical formulas for the compound. Now, molybdenum 3, molybdenum is MO. 3 means it's 3 plus. Permanganate is one of the polyatomic ions we need to know. So it's 1 minus, so the smallest number that both of them will go into is 3. So we need 1 molybdenum and 3 permanganates. So there's our molybdenum, there's our permanganate, and we need 3 of them. And when we have polyatomics, multiples of them, then we write it that way. Now for number 4, we've got calcium hydride. Well, calcium is group 2. Hydride is 1 minus. So the smallest number both of them can go into is 2. So we'll need 1 calcium and 2 hydrides. Because these are elementals, we don't need any parentheses. For C, we want the oxidation number of the elements in the following compounds. Well, the first one involves lithium, boron, and oxygen. And if we look at our rules of oxidation numbers, then we immediately know lithium is group 1, so it's 1 plus. Oxygen is 2 minus. So I'm going to come over here, and I know that the borate ion is BO3 minus 3. So if oxygen, each oxygen is 2 minus, this will be 6 minus, has to equal the charge of the ion, which is 3 minus. So the boron needs to be 3 plus. So we have boron is 3 plus. Now for 3, we have phosphorus and we have sulfur. Now phosphorus, we know what it is if it's negative, but it's not negative because it's listed first. So sulfur will be the negative. It's in the same family as oxygen, so we know it'll be 2 minus. Now if, and I'll rewrite it here, if there are 5 of them, then we have a total charge of 10 minus, has to equal 0. So the phosphorus has to be 10 plus, but there are 2 of them. So 10 plus divided by 2 is 5 plus. Okay. On this one, the question is are they molecular or ionic compounds, and then give the molecular or formula mass. Well, 1 is lithium borate. Lithium is a metal, borate's a polyatomic, so this is an ionic compound. The other one that was asked about was number 3, as phosphorus and sulfur, both of which are nonmetals. So a compound containing only nonmetals is molecular. Okay? Now, in order to calculate the mass, we have 3 times the atomic weight of lithium plus boron plus 3 times oxygen. Well, if we add that up using the periodic table we use in class, we're going to get, if I could copy, 79 0.6322 grams per mole. For 3, which is 2 phosphoruses plus 5 sulfurs, that totals to be 222.27752 grams per mole. The number of digits is a function of which periodic table you use, and it's safer to carry more than less. This is the first of the nomenclature and compound properties.